Okay, sir. Now I begin. Should I begin, sir? Very good afternoon to all of you. I, Dr. S. Tripathi, take this opportunity to introduce our honorable speaker, Dr. D. Dinesh, an agricultural scientist by profession and natural resource conservator by excellence. Dr. D. Dinesh did his PhD Dr. D. Dinesh did his PhD in soil science and agricultural chemistry from Tamil Nadu Agricultural University in the year 2011. Also on the same year, in September 2011, Dr. D. Dinesh joined Indian Council of Agricultural Research as a scientist. Subsequently, after his promotion, now he is working as senior scientist in the ICAR Indian Institute of Soil and Water Conservation at Wasad Research Center, District Anand, Gujarat. He has worked on many research projects and is currently working in 2 research projects as project leader and in the 3 other research projects as associate leader. His major works include assessing the area extent under major land uses through remote sensing and GIS data sets in Mahi ravines, assessing the effect of land use on soil carbon stock and soil quality, assessment of soil nutrient losses through runoff. Dr. D. Dinesh has published several research papers in national and international journals and has authored 2 books also. As we all know that soil is the most essential and exploited natural resource, and Dr. D. Dinesh is an expert doing research on it for its sustainable use and health management. To the proper utilization and management of natural resources such as land, water, agriculture, fisheries, forests, etc. are very, very important for the welfare of humankind and the Mother Earth. So in today's webinar, you all will be listening and learning about the application of geospatial technology and tools such as geographical information system, remote sensing, and global positioning system for the efficient utilization and management of natural resources. I, Dr. S. Tripathi, on my own behalf and on behalf of the entire Paruli University family, welcome Dr. D. Dinesh and request him to commence with his presentation on the topic geospatial technology application in natural resource management. Dr. D. Dinesh, sir.
Thank you so much, sir. I am audible?
Yes, sir. Yes, sir. Please continue.
Thank you so much for your kind words.
Thank you, sir. Thank you, sir.
Let me share my screen.
Sure.
Sir, now it visible?
Yes, sir. It is visible. You carry on.
Okay. I first of all thank and pay my gratitude to the Parle University and the Department of Agricultural Engineering faculties, especially Dr. Tripathi ji, Madam ji. I just want to share my experience with geospatial technology application in natural resource management. This is the one of my near to subject. I just get expertise after my joining the service. So I in this session I am going to share my knowledge in this regard. So shall we go ahead? Sir, it is now clear voice is there? Hello? Hello?
Yes, sir.
Okay. So friends, now in modern agriculture, we know that we start using so much of technological inputs at the one of the biggest uh, uh, event we cross the green revolutions. Now what we are facing in these side effects, we can say the back effect on the agriculture, modernization of agriculture. In this regard, we have to think holistically to approach any scientific development in agriculture. So in this aspect, there are so much recent advancement is happened recently that tools how we are going to use. Let me see one by one. To cover this title, I have planned my lecture like this to cover the little about integrated watershed management, why we should go integrated watershed management, basics of remote sensing, and overview of GPS, fundamental of GIS, unmanned aerial vehicle and drone survey. A little class case study I kept to understand how these tools are effectively used for the resource conservation measures. So before starting, I want to participant to understand the what is the watershed. So we all know in before I mean independence we are doing natural farming. After some times we are just modernized our agriculture through implements like tractor, some chemical fertilizer, new introduced. We will what happened in people are without knowingly, unknowingly using of resources excessively, it causes very severe damage to the natural system. That system is in long run it will affect the whole area and at the last it will go into the degradation status. To avoid this status, we have to work, we have to plan in the holistic approach. That one way is the watershed. Watershed, I think, as engineer in agriculture engineering, they know this is hydrological units having the common boundary. I mean, it was that water flow from the one outlet. So this is simple definition of watershed. So before going to watershed, we have to take the what is the need to go for watershed. Previously, people are working individual aspect like seed production, mass production like that. But in holistically, it will have some detrimental effect to the whole system. So now we have to look as a holistic. Then only we can develop as a socio-economic development we can achieve. So this is the new paradigm shift after 90s. We can say after 2000, we are planning to work as a whole India. There are understand the water resources to challenging task because we have limited resources. We have to allot these our resources based on the priority where we should initially we should start our intervention. For that we have to understand the what is the present condition. For that we are using the modern tools like remote sensing and GIS in watershed planning. So remote sensing it is a one tool. Before that we should understand the what is watershed program. Watershed program is the as a socio-economic program we can say to develop the whole area of the particular to develop the whole area, maintain the sustainability. So these are the some of the information we should first understand to before going to the study the every like basic resources like climatic condition of the area, soil and eco, hydrology, drainage, and land use details and social. So second most that what is the crops, what is the whether it is perennial and annuals, what is the practices they followed, what is the production level, what is the productivity level of particular land, then what is the land management condition, whether they have made some soil or not, then what is the forest management, then water structure is there, anything, what is irrigation status, whether it is rainfed totally or irrigated, partially irrigated like that. So major one is drainage line, whether we have before taking the intervention we have to study what is the drainage on the particular watershed area. Then holistically we have to understand the local knowledge, ITK. These all are some of the resources we have to understand each and every one to the effect. Then only we can plan our program. Any program, especially watershed. So before starting remote sensing, I think nowadays people are very well aware about what is remote sensing. We are day to day life, we are remote sensing unknowingly. Like nowadays we are using the remotes for all the things. Like if you start TV, AC, whatever electronic equipments we are using, we are using just remotes. What is the remote is doing? Same thing we are doing in the remote sensing. Remote, we are just pressing one button, we are sending some signals. In that there is a sensor is there, that sensor is react that signal and give some feedback. Based on that we will see the scene or anything, what changes we want to make, we can make. It means without physically touching any, so any equipment, any object, we will get some information or we will receive some information. See, this is some of the photograph I'm seeing to understand our Earth is covered more of satellites. You see the pattern of satellite is how much it's nowadays. All the countries are launching their own satellites to understand to study their natural resources. So this is the how the system works. This is some outputs of images on the remote sensing images. So we will go by definition of remote sensing. Remote sensing is defined as a technique to obtain information about the object through analysis of data collected by instrument, not physically contact with the object. So that I told we are really using the remotes. It was similarly we are doing sending some signals, we will get some reply. This is the simple definition. So yeah, we will go process. So you see that this is a Earth. Assume that this is Earth. So Earth is receiving some radiation from the sun, atmosphere. So after interact with that atmospheric object, it will reflect. It will first interact and then reflect. So the reflected energy was recording in this satellite sensor. This reflected energy was just digital signals. It was recorded as a binary number. It is called pixel. This information is brought back to the ground station. Then from this collected information, we will get some images output. It is a raw information. We have to process it to understand what is this. So this is the basic process of remote sensing. Now we are doing through aerial also, not space. It is a very high altitude. If you need, we can go using the flying airplane or any airborne vehicle. We can study any part of the country. So this is the overall how this remote sensing evolving. We will see little go back in history. Initially, scientists they want to study any object from the bird eye view. So we see that bird eye views. First, initially they try to keep some sensor cameras from these birds to cover to understand the nearby features. Then they used the balloons, air balloons. Afterwards, they went to flight airplanes, followed by then they went to remote sensing. I mean sensors, satellites. It was making orbiting in the space. This is the overall. How the remote sensing evolving. So in this remote sensing, the basic principle is electromagnetic radiations. We know. Then in this electromagnetic radiation spectrum, for remote sensing, this visible range from the 0.4 nanometer to 0.7 nanometer, it is a visible range. Then reflected IR, then infrared and thermal IR and microwave. These are the regions of spectrum we are effectively using for the remote sensing. Before that, it is not able to sense frequency. So this is the electromagnetic spectrum. You are effectively the energy level, electromagnetic energy, which is reflected with after interacting object. So before that, there are types of remote sensing we can call. One is the passive remote sensing and is active remote sensing. Passive remote sensing is recording energy that is emitted, scattered from natural resources like sun. If sunlight is there, no, it is just not spending any energy for that. It automatically, it was based on atmospheric images, it will reflect atmospheric interference, it will infiltrate and reflect based on the object present in the earth. Whereas in active remote sensing, we are having the own electromagnetic radiation system, which is reflected, scattered, and a signal detected by the system. So we are giving artificially electromagnetic system for the generation. So in the National Space System, there are two types of satellites they used to call. One is the INSAT series, another one is IRS series. So INSAT series is just telecommunication purpose. Whatever nowadays you are using, mobile phones, satellite TVs, all are fully dependent on the INSAT series. Whereas IRS series is the to study the natural resources, to understand the climatic changes. For that we are using IRS. There are major two systems. So as per this satellite is concerned, there are two kinds of satellite we can call geostationary satellites. That's I already told. INSAT series are the geostationary satellites. It was equatorial west to east satellite orbiting on Earth, altitude of around 35,000 kilometers. To make one revolution, it will take 24 hours. It is synchronous with Earth rotations. Whereas polar orbiting satellites are sun synchronous satellites. These are satellites orbiting similar to the sun. We can say this is rotating like if you see, you can see this is the image from this. This is the near polar orbiting satellites. So in such series, we have so many applications we are using. TV broadcasting, business communication, mobile, radio, all are fully dependent on INSAT series. This is like that INSAT series satellites moving here like this. This image is showing. So there is one place in East Europe. It is called Svalbard. This is a major station of satellite observatory. We can say Earth station. Almost all satellites are crossing these stations every day. So there we can get down our database and we can retry. Whereas in India, we are having the Hyderabad NRSC having the Earth station. It was downloading the information from satellites every day morning early morning from 8 to 10:30. So this is small example how they are launching. So to satellite, this is small example how to launch the satellites. It was we have to bring to the altitude of the space, different altitude. That for that they're using rockets. So coming to the application area, so satellite remote sensing having a very wider application, especially in agriculture, not only in agriculture, in all the resource management. So if you take the example, agriculture, it is crop acreage, production estimation, and remote sensing based crop yield models. So nowadays, government are predicting the how much we are going to produce this year. It is based on the remote sensing only. So crop condition assessment and agriculture drought assessment also we can make. Especially soil resource studies, soil mapping in different scales to understand the land capability and the land reliability maps, soil moisture estimation also we can make. So by major objective where I am presently working is land degradations. So mapping and land degradation is the very tricky because these degradations may change year after year. Sometimes it is looking craft, sometimes it is fallow. So we have to understand which is the actual degradation status, like salt affected soil, eroded soils, shifting cultivation area. We can able to detect and may quantify this area through remote sensing. And one of the major area used for this land use, land cover information of satellite imagery to plan the district level wasteland mapping, urban spiral, how much urban area development is there. So where is the growth is happening, we can understand using these images. Major one is areas forest area, forest cover mapping and monitoring also. It is very important nowadays to maintain the forest land, to input a forest management plan, to forest fire and risk mapping, biodiversity conservation, environmental impact studies, grassland. All are the some of the directly or indirectly used remote sensing techniques to understand the resource condition. Next, coming to the water resources, surface water mapping, flood damage assessment, flood risk zone mapping, identification of flood encroachment sites, runoff forecasting. These are the very important area for the water resource studies in the remote sensing applications. In geoscience, to study geomorphical, to make more valuable geomorphological studies, groundwater studies, mineral explorations, geo-environmental and geoengineering studies. So then we can have application in ocean application also. Then we can have the application of geosphere and biosphere program also. And lastly, we can have sustainable watershed development. It was the one of the major area now people are working to get the holistic output. These are some of the satellites launched by the ISRO. So by and large, we can say these platforms, there are three categories. One is the ground-borne, airborne, and space-borne. In ground-borne, we know that we are traditionally doing the surveying. It is ground-borne, and airborne is you can use balloons, aircraft. Space-borne is satellite and space station. Space station is the permanent one. Workplace is there. People will go and there and work and come, like Skylab, Mir, ATP. Whereas satellites are covers the defined orbit and defined intervals. So it will cover the entire Earth in the defined particular orbit and particular time space. So this is one of the picture of the airborne remote sensing. Here we can see that how they are. It is looking like flight. It's having already inbuilt sensor to map the large scale mapping for 1:1000 to 1:10,000 from different digital elevation model. Based on their requirement, we can use this airborne remote sensing. Here we can have advantage of the using the synthetic aperture radar. So many facilities there. This is one of the advances of the remote sensing, airborne remote sensing. So coming to again to overall to give the how this remote sensing is happening, you see from here solar energy is received by the earth object and some are retained, some are reflected. So this reflected is received by the different platforms. So after this received information we downloaded to the earth station, then it getting processed to get the meaningful decision and output. So in the remote sensing, there are 4 technologies very important to understand. One is the resolution. There are 4 kind of resolution is there: spatial, spectral, temporal, and radiometric resolutions. In spatial resolution, we all nowadays using the mobile phones. We know that which mobile having the more clarity in our photograph. Similar, same, we are using sensor to capture the information. So based on that, it will cover the area, how much area it will be able to cover. For the time being, I am just giving some example. Now we are having the Cartosat 2 IRS 1P6. It's having pan image of 5.8 meter. Mean 5.8 meter resolution means whatever object more than 5.8 meter, you will be able to distinguish from these images. If it is less than 5.8, we can't distinguish. Nowadays, people are using list 3, that is having the resolution of 2.5 meter, or you can say almost 6 meter resolution is we can get. So these are the very advanced thing happening. Sensors have now evolved more efficient to cover the area. This is the example for this spatial resolution. Then spectral resolution. Spectral means, so what is the bandwidth we are using in that in this sensor? So refer to bandwidth of the number of bandwidths we are collecting. So we are 4 band is there. Mean all the sensors are having basically first 3 band: blue, green, red. 4th band is the pan or any other band we can keep. Thermal band also we can keep. So for example, list 3 there are 4 bands. You can see that we can see the blue, green, red. We can see here from this map. So based on this area it will collect the information. It will have the resolution this much. This kind of colors we can able to capture and retrieve. Radiometric resolution is the one of the very important to the pixel level. So we are now using it's called bits. It is IRS 1D is using the bits of 6 bits, and list 3 is using the 7 bits. 7 bits means 2 power 7. So how much it will come? How much it will come? So this much of radiation differences we will be able to distinguish from these images. That's why it's called bits. So then temporal resolutions that refers to frequency of collection of data or time interval between the repetitive coverage of area. Suppose list 3 is having the 24 days. Suppose today this list 3 means satellite is crossing today from this Gujarat. Same, it will come again 24 days after the same place it will cover. So it is having the temporal resolution of the 24. Now there are recent developments happen very fastly. So now our satellites coming everyday resolution we can take day by weekly, on even day-to-day activities or day-to-day we can also collect. So these are the information are very much required to make the planning, policy making. So for this, that our Indian remote sensing satellites are very broader, and we are, you can say in the Asia we are the leading remote sensing agency. You can call ISRO is one of the leading agency. So presently I already told that Cartosat 2 satellite we are using for this studies purpose, especially to understand the our agriculture planning, other planning works. They understand natural resources using this Cartosat 2 now. So this information we can get from the National Remote Sensing Center, Hyderabad. So they are having the very big campus in Hyderabad, Balak Nagar, the place called Balak Nagar. So there people are getting training also. If you anybody want to go, you can attend training there also. So there you can say that is the warehouse for the data of the whole India. For entire country, they are having the database and managing the remote sensing informations. Previously, it is called NRSSA. Now it is called NRSC. So coming to the data processing, after acquiring the data, then large data digital database is there. Each picture element is called pixel, means small units. Satellite, you can say screen. It's a very small area. So this is called pixel number. You can say this small area representing like 23.5 meter by 23.5 meter. One pixel will come. So it is all continuing improvement of data electronic computer hardware, software to make possible to meaningful information about the natural resources. So we have to process this information to get the meaningful informations. So coming to the digital image processing, so how we will get processing? Because once the satellite is flowing this horizontal, it having so much error will come, like distortion due to atmospheric condition, weather, terrain, cloud, so much disturbance will come. Based on that, it will tilt horizontally or vertically, even both. So this kind of error is inevitable while studying the digital image processing. So we have to understand correct these errors while collection information. This is called radiometric calibration. We have to take raw data to correct this information. After correcting, we are go find geometric distortions. We can say that is georeferencing. So removal of noise like atmospheric, huge cloud. All these are some interference where we have to remove that. Based on that, we can go for classification to attempt the quantified decision making about the ground feature. What is actually present is there. So there are two kind of classification in digital image processing: supervised classification and supervised classification. Supervised classification means we have to supervise the classes. We have to, if suppose I am from Gujarat, I know the place where I am going to see the images. So I know what is the water body, what is the barren land. If I know physically, I know, then I can classify that using my knowledge to group this similar area, using to identify to digitize the area and to give it to some classes. It will replicate to other classes. It is called supervised classification. Whereas unsupervised classification means, so suppose I am not aware about this particular place where I am studying. So I am giving to the option to the system. It will automatically make some grouping based on the similarity of this digital coverage, pixels. This is called unsupervised classification. From this, we can able to distinguish the water bodies, sandy loam soil, crops, whether it is paddy or sugarcane, like that. So it was both having the advantage and disadvantage also. So we have to choose which is best one while studying. So very important. Next one is very important in remote sensing, that is called ground truthing, because whatever images we are collecting, it was collected almost from ground to almost 8,000 to 10,000 kilometer height, higher altitude. So there are a lot of error will come. So to avoid this error, we are using so many tools, computer software. So it will not able to, computer does not aware about anything about what is ground condition. So then we have to, as a physically, manually we have to check some percentage of area what we have classified based on the signatures reflected in the maps. It is called ground truthing. Ground truthing is very important. Then only we can, if it is ground truth, this value is checked with these images, then only we can publish the map. So otherwise we can't publish any maps. Ground truthing is very important. So I think now I covered little about the remote sensing. Let's go to GPS. So GPS system, all we know, global positioning system. So nowadays it was the one of the, it was little people not aware about. Now without GPS we can't live, like that conditions happen. So all were nowadays we are using all our smartphones. So it was already inbuilt GPS is there inside. Otherwise we can download so many apps is there for to positioning the our system. So let's go to historical of the GPS. Initially, this GPS system was used in the defense purpose. Like U.S. Defense Department, they used to navigate their soldiers' movement of the area because in without knowingly that some troops are crossing the borders. If they will cross their next country in they will having some issues. So that's why they want to track their defense troops in this using some system. For that they started these signals, sending some satellites to the space to give signals continuously. So for that, that GPS of nowadays, whatever you are using GPS, that is GPS nominal constellation, 24 satellites is there. It's having altitude of 20,000 kilometer altitude. There are 24 satellites roaming here and there. It was giving signals entire Earth, at any part of the Earth you can go. So this is very, very important where we are positioning to take the any action. Suppose nowadays we are in mobile, we are Google Maps, we are using where we want to go. Suppose we want to go from here to Ahmedabad, we are type and we will check what is distance, which way we can go. All are through this only, through GPS system only. So let's see how it works. So these are some of the photographs. So let's come to the principles, basics of the. There are in GPS. There are three segments. Is there? One is the space segment where the satellites is there. Another one is the user segment where we are having the receiver. Another one is the ground control segment. So whenever we want to get some positioning, we are switch oning our GPS system. So this GPS system tried to receive some signals from this space segment, and it was same time interacting with the ground segment also. So it will giving the positioning of so much of signals are receiving from this point and sending this receiving this much signals and sending this much signals to understand the where we are standing. So these are some of the monitoring session in USA. Whatever now we are using GPS, it is US based system only. Recently, India also started its own GPS system, satellites. So there are, I already told, this is the one of the basic arithmetic we can do. Positioning up to point the any point, we need 3 points to locate. Similarly, to get the more accurate in the GPS reading, whatever we want positioning latitude, longitude of the particular place, we are when we are switch oning these satellites, we need at least minimum 3 or 4 satellites we need to get the more accuracy. How it works in the GPS satellites, having there some atomic clock is there. So whenever you start using GPS, first of all we have to check whether our system, our handheld GPS having the proper day, time, and having the particular position. Well, it was having this getting signals clearly and receiving signals clearly. So based on that, we will able to locate the where we are standing. So this is the basic triangulation method is using for this positioning of the particular point. So there are two kind of GPS is there. One is the absolute or point positioning system. Another one is the differential positioning system. This is called DGPS. You see here the down one is the DGPS. This one is the handheld GPS. So this is simple point positioning we can cover. Whereas the DGPS we can make survey using this. So to get the altitude of any particular place to make the DEM digital elevation model, these are very recently nowadays using people of this DGPS to get the actual positioning of the any big land uses. So coming to the, I think now I covered the little about GPS. Let's go to GIS. So this is the Robert Thomson is the father of GIS. So this is simple geographic information system. We can simply understand this. We are having so much information data. We have to pull it and get it the received information. So this is simply we can call software to make this smart map. So what is GIS? This it visualize, manipulate, analyze, and display spatial data. So GIS having this is the basic six things is doing. It was capturing information and store, retrieve, manipulate both spatial and spatial data. So I will come this spatial and spatial data later to create various planning scenario. So simple definition, GIS is the combined layer of information about the piece of place where you are giving better understanding of the place. So like wherever you are sitting, you will need which street, which building, customer, like that. So it was just merging the, stocking the maps to get the more information. So why we should use GIS? First I will go one by one. To improve the organizational integrations. So in any in government department, all the companies, they are using the various kind of informations that we have to organize the information which in a particular manner sequence. Then only we can get meaningful information as and when required. For that, we have to give the information in a particular GIS enable mode. Then only we can able to understand these resources effectively. Then make better decisions. If you know the positioning of these resources, how much is there, what is the quantity, then only we can take decision whether we should use now or we can use later. We can say prioritization of the any resources, we can use this GIS. To make maps. So finally, I think this simply is mapping software. It was having the physically, previously people would take so much time to make this integration of maps and get it meaningful information. It takes so much time and manpower. Now using this GIS, even within time we can make some more information with a simple time, in small time. So here I'm just giving some examples, mapping where the thing is there. Means it's for nowadays we are using in mobile also. We are just checking while moving. Suppose we need to attach. So where is hospital? Where is the petrol station? Where the thing is there? We are just typing in Google. We'll get this is the position where we are having the petrol pumps. Here is hospital is there, temple is there, hotel is there, like that. So we have to object wise. We have to capture the information using GIS only. We have to quantify. Suppose any city is there, we can easily how much area is the covered by the covered particular crop or particular pesticide, pest is affecting. All we can quantify using the maps. If you have the basic information of that particular place. So density. What is the population density of the city of any city? You can, if you understand that urban development, we can easily understand how much density of the population is there. So what is the insight? So if it is if you are very big cities, if you look at the schools, how to identify if suppose anything fire action is happened. So simply they are used to work out the searching the place and navigating to reach that place very shortest time. We can use this GIS. So finding nearby, I already told this previously came. So where is the nearby hotel is there? We have to understand the path, which is the shortest path to reach that place. So changing map. So what are changes? It is 10 years before. What is the condition now? What is the condition? We can call change direction. We can use using the map changes. So this is the overall system, how its GIS database working. One is the major spatial database, that is the latitude, longitude of the area, particular point. Then non-spatial database, it is called place, name, whatever things. It is doesn't having any latitude, longitude. That is called a spatial data. So these are the user in interface, input, queries, updation. We can give the all these things. We can lay out the maps, chart, tabular information, query results and reports. We can easily generate using this software. So there are majorly three files system of using in GIS. One is the point, linear, and area. So point is that we a single value, like you can call the well. Where is the well is there? Where is the electric pole is there? Like that. This point data. Where is water body is there? That is point data. Single point. Where linear feature means it is connected to cells of that priority length, like road, river flowing, street. These are continuous features. It is called linear features. Third one is the you can call this is the combined area. So little big area. We can say group of connected cells like field, any water, big area, town, city, like that. We can geometrically we can call this is the these kind of three major features are using in GIS system. In the data model system, there are two systems: raster and vector. We as engineers we know. Raster is the rectangular grid or dots called cells. You can call pixel with the values there. Vector is the model data using the line segment, point or point segment representing x, y coordinates like x, latitude, longitude, locations. These are the features that are using in the GIS system. So let's come to the remote sensing tools for watershed management. So previously that people are using the very big scale map, spatial information, 0.5 to 56 meter, spectral of 3 to 200 bands, temporal of 1 or 2, 24 days. But now it all old. Now it very improved versions are coming nowadays. So in this we are using GIS, raster, vector, and web-based GIS also we can make. We are using the GPS to point out any places in the watershed. So all these are the some tools to understand, to effectively planning the watershed management. So I'm going next. Time is short. So baseline study is to understand. We should understand. We should plan for the watershed characterization, soil and land use, slope, drainage. So many things is there. We can using the baseline study. So we can action plan which resources we have to take first. So this is the tools. We can even watershed monitoring, spatial modeling, spatial decision making, dynamic prioritizations. We can say that where we can resource we can pool now presently, where we can save later, like that. Prioritization is very important in the watershed management to because we have the very less resources for the treatment the waters and lands. So next coming to drones. I think people are nowadays very fond of using drone, UAE, unmanned aerial vehicles. But before, those are little difference. By looking, both are same, but it's a little difference. Drone is the dynamic remotely operated navigation equipment. It is having zero intelligence. Means drones are having its own intelligence. It just we are launching any very programmed missions. It will cover particular course or time and return back to same place. For example, drones we are using nowadays in big malls, marriage halls to capture the events. Very small area to cover the overall bird eye view. For that, drones are using. Whereas UAE, this it is having higher version. You can say that more higher automatic intelligence system is there. This UAE, we can control, we can return payload, data. We can give some signal and we can take that imagery there itself. So these are some positioning, airspeed, heading, altitude we can change as when required. These are the major difference between the drones and UAE. So this is the, we can say, advanced condition of the geospatial technology nowadays people are using. So why we need UAEs? So nowadays very fast moving, we need information in real time basis. So flexible as per when required, low nowadays data, low cost, high spatial information, high spectral resolution is there. Retrieving base biophysical parameter also we can do. So high temporal resolution also we can get from these UAEs. So coming to the major differences of satellite remote sensing and UAE remote sensing. Satellite remote sensing reliable, advantage is reliable, need not to have special skills. We can having special skill but not much as compared to UAE. But disadvantage of the remote sensing is the lower resolution, quality of resolution of data is imagery obtained by may not be sufficient to accurate diagnostic, easily affected by the bad weather conditions, non-availability of data in the record whenever you record, like during monsoon time, expensive to develop the launch the maintenance of these satellites. Whereas UAE is easy deployment, as and when we can play, we can collect information. As a mission mode, we can complete in a flight crew very quick time. Flight need not be scheduled. We can take whenever condition is improved. We can take availability of data is imagery after the flight. Immediately we can get data. Super high resolution spectral and spatial image you can take, less time consuming compared to conventional. Drone program to return to home even case of link is lost. So disadvantage of the UAE is the significant experience required to fly and easily restrictable. So majorly we can say compare this UAE is complementary, fill the gaps, data gaps between the satellite remote sensing and ground surveying. So we'll go for the case studies. So in the case study, actually I want to show some demo. I think this can't be a system will not support, but anyhow I will cover the how for the demonstration purpose. I will say how the watershed analysis tool are using in ArcGIS. So these are some simple steps. We will perform the ArcGIS tool. If you loaded your digital elevation model in the ArcGIS system, we can generate also them from using if you are having the raster data of the any place. If you know altitude of these all the points, we can generate one digital elevation from this ArcGIS. Then we can go for the flow direction. From this digital elevation model, we can understand where is the low is there, where is high is there. We can understand the whole profile of the elevation profile. Based on the elevation profile, we will understand the flow direction. Where is the water moving is there. So if where very deep is there, we can understand the flow accumulation, where it is accumulates. To identify and removing the sinks. If you some past these images, we can remove that excess value. Then we can go for stream networking. We can network these streams very effectively, first order, second order. Then based on that, we can go for stream links. Stream links means we can connect through the higher to lower order like that. So finally, we will get the watershed analysis. We can output will get the delineated watershed. So purpose of the JS2 in the watershed management is majorly to delineation of the watershed. So you can see this small example I give. This is we can sink some areas, some missing values that we have to fill. Then compute the flow direction. Then compute the flow accumulation. Then it will automatically generate the watershed. So I will take one case study from this where I was worked in previously in Tamil Nadu, place called Ooty. You all will know this is one of the important tourist place in Tamil Nadu. So where this is the one watershed, name is called KG41 watershed, very old watershed. So our center want to take this watershed. We are just planning how we are planning the resources of this watershed. So we have to take these lat long elevation, soil, what is the soil type, what is slope condition there. We all features we are collecting. So this is the actual initial image of what area you see that yellow lines where we are delineated our watershed. So important problem in this satellite image is the that image we are getting during monsoon. It is a very much problem because of cloud cover. So we will not able to get the cloud free. Suppose we will not be able to get the cloud free image, then it is very difficult to delineate and identify the features in the ground level. So this is the, for example, this is PAN sensor IRS1D. There are some limitation also is there in the remote sensing because the some while working we will get the so much limitation will come. Suppose spatial boundaries with respect to land use could be obtained. We can get the through manual mapping we can digitize and we can try to take manually delineated to also system. Same contour tone created in different land use units. Two different contours are associated with the same land use units. Sometimes what happened? It was because of the color changes we will not able to distinguish the particular place whether it is coming classes or that classes. This is one of the major problem in these remote sensing satellites. This is one of the small example. IRS1C, that is you can say Andhra Pradesh area. Same image you can see. This is the 96 different 1st January and February month. We can based on this we can classify this area is maximum area pulse covering, whereas this area is the paddy area, rice cultivation area is there. So based on this feature, we do simply classified from the existing data. So this is one of the example I am giving here. This is the one of the comparative study to how much variation we can get through remote sensing and manual survey. So this is table is describing that. So based on the remote sensing, where our area is coming 22 means suppose this much hectare area is coming. In manually 276, here is 3 only. Whereas in T area, T plantation area is 79 million hectare, 70 hectare, where it is manually it is 19 hectare. The variation is more. So this is the very big hurdles while using the remote sensing data. Because sometimes what happened, this area of the plantation is similar to other land features like other crops, like habitations, grassland, like that it was swamp area, like it was not able to distinguish clearly. That's why this kind of variation is given. So this is one of the negative aspect of the remote sensing information. So this is some of the examples I'm giving. Suppose those who want to study the imagery, we can procure the data from the NRSC. This is the some cost of the first single image from 6,000 starting. You can, as per now it is previously it is very difficult to get information. Now the government is open to the open database policy. More than 1 meter resolution information anybody can get. Less than 1 meter only it's protected by the defense. So other database we can easily purchase for any study area, any purpose. So GIS again it's various tools is there. In this one tool is the field survey, remote sensing survey field. There are so many information is there for getting the simpler task to get the more accurate information using the GIS. So all we know that nowadays people are using the Google Earth. Google Earth is also it's 0.6 meter resolution image is free of access. You will get some clarity information. Using this, you can some without free of cost also. If you want to study any area, we can use Google image also. So this is the small example of the how the Google image of the Ooty area, our research farm in Ooty. So finally, I want to say that we are nowadays all fully depend on the other countries' database like US, other countries. But in India also is generating one database for geospatial. It is Bhuvan, bhuvan.nrsc.gov.in. We will get the all our authenticated information about the Indian special information using this Bhuvan. Some are free of cost, some we have to pay. We have to register and we will access. We can able to access the all the information of the over our India. So I think I try to cover the very fastly. So let's go speed.